I want to talk about how to sketch functions in factored form. So if we have a function here that is in factored form, we can make a quick sketch of this graph. It's not going to look perfect, but it'll give us an idea of what's going on in the graph. Usually the most useful thing here to find at the beginning are the zeros. And the zeros, or x-intercepts, are just points that we can find on the graph to tell us what the curve is going to do. So zeros that's just another name for x-intercept. So if they say find the zeros, they mean find the x-intercepts. And then we're going to go ahead and sketch what these are. Now zeros will be whatever solves. Remember that for the x-intercept we plug in a 0 for the y, which is the same as f of x here. Whatever solves this so that'd be an x plus 2. Whatever solves this equation here. Sorry, my handwriting got kind of ugly as I got to the top of the screen. So if we set each piece here equal to 0, we should be able to solve for what the zeros are. And you should be able to tell this without writing this out, but I'll write it out anyway just so you guys can see. So if we set each of these equal to 0, if I add 1 here, I get that this 0 is x equals 1. If I subtract 4 over here, I'll get that this 0 is x equals negative 4. And if I subtract 2 over here, I should get that this 0 is x equals negative 2. All right, so that should get me my 3 zeros. Remember, zeros are the same as x-intercept, so let's plot those right now on the x-axis. So I've got a 0 at negative 4, I've got a 0 at 1, and I've got a 0 at negative 2. And now we just have to figure out what this graph is doing. Is it, going to curl around this way? Is it going to do something like this? And we can figure this out by looking at the degree of the function here next. So we'll look at the degree. So to find the degree of a function, usually we look at the highest exponent term. Since this is in factored form, we could FOIL the whole thing out, but it'll be easier to just look at the x's in each. And if I multiplied all these x's together, that would give me a degree of the function. So in this case, this first parentheses would give me an x. This second parentheses would have an x squared in it because of that squared up here. And this parentheses would have just a plain old x. So if I multiplied all these guys together, I would get an x to the 4th. Okay, so that would give me the degree of this polynomial. If you wanted to FOIL the whole thing out, you could. Just you'll take a little bit more time. You'll still get an x to the 4th as the leading term. So if you don't believe me that x to the 4th would be the leading term here, try FOILing this whole mess out and see what you get. Okay, so the degree in this case would be 4 then. That's a positive x to the 4th, so the degree is 4. And even functions, so this is one thing to note here, is that even functions have the same behavior at the ends. They either both go up, if it's a positive x to the 4th or x to the 6th or x squared or whatever, or if it's negative, they both go down. Kind of like parabolas. Parabolas are even functions, so they both ends go up or both ends go down. Since this x to the 4th here is positive, they're both going to go upwards. Okay, so both of these ends are going to open upwards. Now, that means that what I'm going to do here is just when I sketch this, I'm going to draw both ends here kind of coming up out of the sky. And now all we have to do is see how this thing is connected. So the final thing we're going to look at here is the multiplicity. We're going to look at the multiplicity of each 0 here, and that's going to tell us what to do at each 0, whether we pass through or whether we touch and turn around. So if we look at this first 0, x equals 1, that 0 only appears once, so it has a multiplicity of 1. Or another way to think of that is the exponent on x minus 1 is just a 1. X plus 4, however, appears twice. It has an exponent of 2. So if it's a repeated 0 here, it's got a multiplicity of 2. This one, again, there's an invisible 1 here for the exponent, so negative 2 would have a multiplicity of 1. Now, here's the next thing we need to talk about. Odd multiplicities, when we graph these, if I have a 0 with an odd multiplicity, it'll just pass through. So this is, I know it's a basic way of talking about it, but it'll just pass through the 0 graph and continue on its way. If it's an even multiplicity, so if the multiplicity, I'll sneak this down here. So if we have an even, I'll abbreviate here, multiplicity, and we have our graph, it'll do what I call, it'll touch it and turn around, or it'll be tangent where it touches at one point and then goes on its merry way. So it will touch here and turn back around. So it touches the 0 at one spot, but it will not pass through. So let's start here with x, actually let's start all the way on the left. So this first 0 here is -4. This is an even multiplicity, so when I start connecting the dots here, this is going to touch and turn around. Okay, so that takes care of the first 0. The next 0 here is at -2. That's an odd multiplicity, so instead of touching and turning around, it's just going to pass right through. And then the last 0 here at 1 is an odd multiplicity, so we're just going to pass right through. There's our graph. It looks like a little W shape. If your points don't match the end behavior, you either have the end behavior here wrong, that both go up, or you also maybe turn the wrong way on one of these multiplicities. Okay, so that would be a quick example. Let's try another one. Go a little bit faster on this one. So I'm going to sketch this the exact same way I did. We'll start by looking for the zeros. Okay, so if I'm looking for the zeros here, I have zeros at -3, I have zeros at 4, and at 1. So those are my 3 distinct zeros here. I'll also sneak in the multiplicity while I'm here. I'll come back to that later. So the multiplicity will be on this one 3. This one will have a multiplicity of 2, as will this one. Okay, and then finally I'm going to look for the degree of the function. That'll tell me what the ends are doing. And on this one, again, if I FOILed this out, this would have an x cubed. If I FOILed this out, this would have an x squared, and if I FOILed this out, this would have an x squared. So if I multiply these all together, I'm going to get an x to the 7th, so the degree here would be 7. Okay? So that leading term is going to kind of tell me what's going to be going on. Now, if it's an odd degree, we said even degrees will go like this. And odd degrees, and they could both potentially go down. So it's going to do one of these two things. If it's odd, think of it like a line. One end will start low, the other end will start high. So if that's a positive leading term, this is a positive and a negative, then the first one will go low and end high. If it's a negative, it's kind of like a negative slope where it starts high on the left and ends low on the right. So it starts high on the left and ends low on the right. So this one was a positive x to the 7th, so that's going to be a positive leading term. Let's go ahead and graph this here. So we've got zeros at -3, at +4, and at 1. Okay, and I'm going to start at -3. Now, I know that the end behavior, since this is a positive x to the 7th, should look something like this. So I'm going to sneak these ends in here, and then I'll draw around these. I got to start from here to connect the dots. This -3 has an odd multiplicity. That means I'm going to pass through. Now this next one has we're actually at the 1 next. The 1 has an even multiplicity, so I'm going to touch it and turn around. As well as this 4 here also has an even multiplicity, so I'm going to touch it and turn around, and that kind of matches the end behavior here, and that's a sketch for my graph. Okay, so once you get good at these, they're pretty quick. It's a fast way to sketch the graph. Again, so even multiplicities touch and turn around. Odd multiplicities pass through. There's a little bit of extra stuff that goes on here, but don't worry about that here for this lesson. Okay, final one. So if it's not in factored form, we have to get it there first. So I'm going to start by factoring out a greatest common factor here. So I can take a -x out of this guy here first, and then I'm left with x squared minus, that'll be x squared minus 4. And then if I factor this a little bit more, I can now factor the inside to x plus 2 and x minus 2. So that gives me now my function in factored form. Again, I'm going to find the zeros, the multiplicity, and the degree. And when I say degree, I'm also looking for that leading term. That's just as important as finding the degree to see if it's positive or negative. So first off, my zeros. I've got a 0 here. If I set that equal to 0, or if you think about it this way also, that would be a 0 at 0. So an x-intercept of 0, we've got an x-intercept of -2 and +2. Now if we look at the multiplicities, none of these have any repeated factors or exponents up top, so these all have a multiplicity of 1. Okay, so that means I'm just going to pass through every single point since those are odd numbers. Finally, the degree, if I multiply, actually, you know what, it's already multiplied out up here, so I can see that the leading term is -x⁻³, so the degree here is 3. Okay, so the highest exponent term would be a 3. Now, again, we said that earlier, odd functions will either start low and end high if it's a positive x to the odd power, in this case x⁻³. But since this x⁻³ is negative, it works kind of like a negative slope where it's going to start high and end low. So our graph should be doing something like this, unlike the last one where the leading term was positive. So it's basically just going to flip-flop the graph around. So when we start this, let's graph the zeros. So we got zeros at 0, -2, and +2. And we know that it's going to start high on the right, or excuse me, on the left, and end low on the right. All right, so now when we're going through this, we'll start at -2. That's an odd multiplicity we pass through. And in fact, all of these are odd multiplicities, so I can just go ahead and pass right through each of these, and then there is our graph. So again, that's how you sketch functions when they're in factored form. Find the zeros, find the multiplicity to decide whether you pass through if it's odd or touch and turn around if it's even. And then find the degree. That tells you what the ends are doing. And also you have to look at the sign on the leading term. If it's negative, it flips things upside down. So if it's a positive x⁴ or any even power, it would be like this. But if it was a negative x⁴, they would both be down. We already talked about the odds, what they do. And then once you have that, just make sure you kind of plot your zeros and then start connecting the dots.